In the problem statement, we are given a n cross n board and there are three pieces arranged in L shape. We want to find out whether any piece can reach a certain square in the board by doing some number of moves. In one move, we can move a piece horizontally, vertically or diagonally such that it jumps over a piece adjacent to it in the direction and sits in the square next to it. Let's see some examples and make some observations. So here is the scenario, and we can see that if the arrangement is like this, then we can cover this row and this column easily by doing the operations like this, or we can just do the operations for the column like this. Now how can these blocks moves like this? We are covering this column, but what other columns can we cover? So if we make the move like this, make it jump over this and this and this, then we got this in place. Like now this row is covered, this column is covered, and this row is already covered. So this is one way in which we can move the pieces. Another way is like if it is like this, we want to just move it to some other row, we want to just cover some other row other than this. What we can do is we can do this, we can do this. Now this row is also covered. In the previous position this row was covered, so we can see we can move like this and this, and we can cover this row, but there is no way we can cover this row. This row gets covered, but this row cannot be covered if the initial position is like this. Similarly, if this column is covered, this column cannot be covered because the very next column that we can cover is something like this. Let's say this and sorry, in this way we can just do it like this and this, and we can cover this column. But there's one more thing. If we want to just traverse into some, basically say column from here to here, we need some extra row which is above this row or this row. If any both of the rows are not present, we cannot go into the next column. Like for moving into from this column, what we can do is we can use the moves like we can do like this, and then we can do something like this, and we can do like this and this. Now we moved into this row, but we used the extra row in this one. And similarly, if we want, we can move to the next row by using some other operations. Like we can do this, we can do this, and we can do this. Now we got to the next column, but we used this row also. Initially the position was something like this, so we're using one more row in order to get to the next column. So we can generalize it like for moving, first of all, if the structure is like this, the number of rows or columns which we can cover are uh, this. We can cover this column, we can cover alternate columns, and this row, this row, this row, and this row. So these are the number of rows which we can cover. If this black piece or some other piece lies in these these squares, then only we can cover it, otherwise we cannot cover it. So the condition that we checked, that we should have a gap above or a gap below for moving, a gap in the above row or the below row for moving in a column is valid. But because but if the grid is n cross n, we just don't need to check that. We can just check that if the row is, if you're just checking in the column, so this column is this column minus this column is divisible by 2. That's the only thing we need to check, because the condition that we were checking, that upper row should be empty, was for this type of a case. Suppose let's say if the row was ending at here and we have just this grid, then we could have said that we can't move into this row, or we can't move in this row, this column basically, and this column basically. We can move into this by doing this, but we can't move in this point. But because it's n cross n grid, then we just don't even need to check that condition whether the upper row or the lower row is empty or not for moving to the next column. So the implementation of code goes like, by the way, there is one more edge case, like if our pieces are aligned something like this, then we cannot move anywhere other than these rows and these columns, because we can't move in this column and this column. Only column which we can move is this, and only row which we can move in is this. So this is for this arrangement, and similarly for this arrangement, the only row which we can move in is this, and the only column which we can move in is this. Similarly, if the pieces were arranged like here, the only row was this and only column was this. Similarly for this arrangement, like this one. And now we can see the code. So initially we take the input of the rows and columns r1 c1 r2 c2 and r3 c3. We find the position of the element which is present in corner, like which is present in the corner of L. Like if the arrangement is like this, the element which we are talking about is this one. If the arrangement is like this, the element which we are talking about is this one. If the arrangement goes like this, then the element is this one. Now just a second. Yeah, so have we take the inputs r1 c1 r2 c2 and r3 c3, then we can just check the corner element with the help of which row is repeating twice and which column is repeating twice. There are better ways, but in the contest I actually implemented it like this only, which seemed to be easier, and it's not that clean code which I would like to say. And then we can just check if the distance of the column which we got which the block the so there is one column which we want to move on, so we'll check if the row of that piece minus the row of that corner element model is 2 double equals to 0, which is that alternate. If we just go by alternating, then we can reach that position. And similarly we can check for the column, if the column of the grid which we if column of the piece which we want to own minus the column of the corner element is divisible by 2, then we can check the condition that these are not the cases where we are getting on the coordinates of both. If we are just getting on the coordinates of both, the only row and only column which we can go on is the row and column row A or the column B. Otherwise we can just print yes if A minus r modulus 2 is equals to 0. Otherwise we can just print yes and we can just return. So that is the stuff for this question. So thank you for watching.